Pluto, a far-off and cryptic divine body, was once important for our planetary group's planetary family. However, recent disturbing explanations from notable astrophysicists like Neil deGrasse Tyson and Michio Kaku have pushed Pluto back into public consideration. They have made a surprising discovery. Pluto may be on a potential crash course with Neptune. But how could such an event occur, and what might the results be? Is this a rare cosmic oddity, or is there something more to this impending celestial impact? Join us as we explore the possibilities of a potential Pluto-Neptune collision. Pluto, once classified as a planet but later redefined as a dwarf planet due to its unique orbit, continues to captivate the scientific community. According to recent research by leading scientists, Pluto's trajectory is alarmingly close to Neptune's orbit. Renowned astrophysicists like Tyson and Kaku are raising alarms about the potential for a catastrophic collision between these two celestial bodies, a scenario that could pose a significant threat to Earth. But how could such an event happen? Unlike any other planet in our solar system, Pluto's journey around the Sun is highly unusual. It takes an astonishing 248 years to complete just one orbit. Since its discovery in 1930, Pluto has not yet finished a full revolution around the Sun, adding to its mystery. However, Pluto's orbit is not just slow, it is also highly elliptical, vastly different from the more circular orbits of the larger planets. To complicate matters further, Pluto's orbit is tilted at an angle of 17 degrees to the plane of the solar system. This inclination makes its path far more extreme than those of other planets, adding layers of complexity to its movement. One of the most intriguing aspects of Pluto's orbit is its relationship with Neptune's orbit. For approximately 20 years of each cycle, Pluto moves closer to the Sun than Neptune does, defying what we might expect based on the usual arrangement of planets in our solar system. This naturally raises the question, why hasn't Pluto collided with Neptune? The answer lies in the gravitational influences of other celestial bodies, especially the giant planets. The study of Pluto's orbit began soon after its discovery. Early astronomers were puzzled by its peculiar path. Unlike other planets whose orbits align somewhat with the ecliptic plane, Pluto's orbit stood out due to its steep inclination and elliptical nature. The realization that Pluto's orbit crosses Neptune's was a major point of scientific interest. Despite these anomalies, the stability of Pluto's orbit is a remarkable feature of celestial mechanics. The phenomenon known as the three-body problem comes into play when studying the movements of Pluto, Neptune, and the Sun. This problem involves understanding how three celestial objects interact and influence each other through gravitational forces. Predicting their paths is a complex task, and this is where terms like AIML libration, scope libration, and VZK wobbling become relevant. AIML libration refers to the fact that when Pluto crosses Neptune's orbit, it remains at least 90 degrees away from Neptune, ensuring their paths never intersect. Scope libration describes the vertical movement of a celestial body in its orbit. For Pluto, this means that when it gets closest to Neptune or another large planet, it is positioned above the plane of their orbits, providing additional protection from potential collisions. VZK wobbling, named after researchers VZ and K, explains how gravitational forces from Pluto, Neptune, and the Sun interact, keeping Pluto's path stable despite its seemingly irregular behavior. Although Pluto's orbit may appear erratic, these stabilizing mechanisms ensure its consistent motion over long time scales. These intricate forces help maintain Pluto's orbit, preventing it from crashing into Neptune or veering off course. The three-body problem is crucial for understanding how orbits shift due to the gravitational influence of different objects. Studying this helps us gain deeper insights into Pluto, our solar system, and even distant celestial bodies and their stars. Mathematical simulations conducted in the late 1980s revealed that despite Pluto's stabilizing factors, its orbit remains chaotic. Small changes in its initial conditions could lead to significant variations over millions of years. However, despite this inherent unpredictability, Pluto's orbit remains stable over incredibly long timescales, effectively keeping any potential disturbances in check. Recent computer models have provided new insights into how the gravitational effects of giant planets like Neptune, Jupiter, and Saturn influence Pluto's orbit. These models show that Pluto's relationship with Neptune is unique. For every 2 orbits Pluto completes around the Sun, Neptune completes 3. This resonance helps stabilize Pluto's orbit. However, Neptune is not the only force at work. Jupiter's gravity plays a crucial role, as does Saturn's, providing additional stability. These simulations demonstrate that Jupiter's gravitational pull alone is strong enough to keep Pluto in a stable orbit for billions of years. Together, Neptune, Jupiter, and Saturn work in tandem to keep Pluto safely on its course, avoiding catastrophic collisions or other disruptions. These gravitational forces are essential for maintaining order in the solar system. Without them, the system would be far more chaotic, with planets and dwarf planets like Pluto potentially colliding or being ejected from their orbits. Understanding Pluto's orbit is crucial to gaining a clearer picture of our solar system's dynamic nature. Pluto's case serves as a prime example of how even the most seemingly unstable orbits can achieve stability through the intricate interplay of gravitational forces. It also underscores the importance of continuous observation and study to better understand our place in the universe. The study of Pluto and its orbit highlights the unpredictable nature of celestial mechanics. The concept of orbital chaos, which refers to the extreme sensitivity of a body's orbit to its initial conditions, is clearly evident in Pluto's case. Even the smallest change in Pluto's position or velocity could significantly alter its orbit over time. Simulations have played a critical role in helping researchers understand Pluto's movement. These computer models use complex mathematics to simulate how Pluto and other celestial bodies interact gravitationally. By tweaking small variables, astronomers can see how minor changes can drastically affect Pluto's long-term orbit. In the late 1980s, these simulations revealed something fascinating about Pluto's orbit. While it may be stabilized by factors like AIML and scope libration, it can still be unpredictable. Even slight differences in Pluto's initial position or speed can lead to dramatic changes in its orbit over long periods. Despite this apparent chaos, Pluto's orbit remains relatively stable, enduring for billions of years. This demonstrates that while its path may seem chaotic, there is an underlying order to it. Predicting celestial events, especially those involving chaotic orbits like Pluto's, is a formidable challenge. The unpredictable nature of these systems means that long-term predictions come with uncertainties. While simulations are invaluable tools for understanding and forecasting the movement of celestial bodies, they also highlight the limitations of our predictive abilities. Any slight error in initial conditions can lead to drastically different outcomes, making the chaotic nature of Pluto's orbit serves as a reminder of the constantly evolving and dynamic universe we inhabit. Even as we make great strides in space exploration and understanding the cosmos, Pluto's orbit reminds us of how much remains unknown. Understanding the gravitational interactions of giant planets with Pluto provides valuable insights into the broader dynamics of the solar system. It reveals how the positioning of each planet can have far-reaching effects, influencing the stability and trajectory of other bodies within the system. So why are astrophysicists raising concerns about a potential collision between Pluto and Neptune now, after so long? Neil deGrasse Tyson, a leading astrophysicist and an influential figure in popularizing astronomy, offers a thoughtful perspective. Tyson, known for advocating Pluto's reclassification as a dwarf planet, sees this shift as a reflection of our ever-evolving understanding of the solar system. He does not view Pluto's reclassification as a demotion, but rather as an advancement in our knowledge of the various bodies orbiting our Sun. Tyson's approach to celestial mechanics is rooted in continuous learning. He sees Pluto's erratic orbit as a sign of how much more there is to discover in space. The fascination with questions, such as the potential for catastrophic events between Pluto and Neptune, continues to captivate scientists and the general public alike. With other heavenly bodies, Pluto's direction will continue to be shaped. Surprisingly, even the steady change of the Sun into a red giant and its eventual collapse into a white dwarf could alter the gravitational landscape of the solar system, potentially affecting Pluto's orbit. While the probability of Pluto colliding with Neptune in the near future seems far-fetched, The inherent uncertainty in predicting celestial dynamics over such vast timescales means that anything is possible. The forces at play in orbital mechanics are powerful and complex, and even the slightest change can accumulate over billions of years, potentially leading to significant shifts in the orbits of distant objects. This uncertainty in space exploration brings us back to a core principle. The more we learn about the universe, the more we realize how much remains unknown. The study of Pluto and other distant objects in our solar system continues to challenge our understanding of planetary orbits, gravitational interactions, and the fundamental laws that govern the cosmos. As scientists continue to observe Pluto and Neptune, new data may either confirm or challenge our current theories. While the possibility of a catastrophic encounter between Pluto and Neptune may seem fantastical, it serves as a reminder of the mysteries that space still holds. As our tools for space exploration advance, providing us with more precise ways to simulate, predict, and observe these cosmic phenomena, the potential for a collision or near miss between Pluto and Neptune remains a compelling example of the complexity and unpredictability of our solar system. Whether such an event will ever occur is unknown, but it highlights the ever-changing nature of our cosmic environment. The story of Pluto's orbit invites us to think beyond what we currently know and to embrace the mysteries of space. It challenges us to look at the universe with fresh perspectives and to remain open to the surprises that lie ahead. As scientists continue to unravel the secrets of the universe, we are reminded that we have only begun to scratch the surface of what the cosmos has in store. Whether Pluto and Neptune will continue to orbit safely or one day experience a cosmic collision remains an open question, one that only time and further discoveries will answer. As we progress in our understanding of the universe, the narrative of Pluto's orbit serves as a symbol of the mysteries that continue to puzzle and excite scientists. The potential for a collision or close encounter between Pluto and Neptune, though unlikely in the near future, is a reminder of how much we still have to learn about the vastness of space. These celestial events, no matter how improbable they may seem, invite us to keep questioning the workings of the universe and the fundamental forces at play. In the ever-expanding field of astronomy, there is always more to discover. As we delve deeper into space exploration, the tools and methods used to study distant worlds like Pluto are improving. Advanced telescopes, space missions, and more sophisticated simulations allow researchers to track these celestial bodies with unprecedented accuracy. These advancements provide new insights into the mechanics of planetary motion, gravitational interactions, and the long-term stability of our solar system. One of the most exciting developments in the study of Pluto and its orbit is the continued progress of observational technology. New space missions are constantly being launched with the goal of exploring distant objects in the solar system. Missions such as the New Horizons probe have provided invaluable data on Pluto and other Kuiper Belt objects, offering a closer look at the characteristics of these faraway worlds. With each new discovery, our understanding of these distant bodies becomes clearer, and we gain deeper insight into the processes that govern their motion. The fact that Pluto remains an object of interest and study, even after its reclassification as a dwarf planet, speaks to the ongoing fascination with this distant world. Pluto may no longer hold the title of a planet in the eyes of the scientific community, but it still occupies a significant place in the public imagination. Its reclassification has sparked debates about the definition of a planet, the complexities of our solar system, and the ways in which our understanding of space is continuously evolving. This ongoing study of Pluto's path reminds us of the fluid nature of scientific knowledge. What we believe to be true today may change tomorrow as new data emerges and new theories are proposed. The possibility of a future collision between Pluto and Neptune is a scenario that cannot be completely ruled out, but it also reflects the broader theme of unpredictability in space. The very nature of the universe is such that we can predict certain events with a degree of certainty, yet even the most carefully constructed models can be overturned by new findings. The pursuit of knowledge in astronomy is driven by the desire to comprehend the fundamental workings of the universe. By studying Pluto and its relationship with Neptune, scientists are not only examining the specific dynamics of these two celestial bodies but also gaining a deeper understanding of how gravitational forces shape the motion of all objects in space. The insights gathered from these studies have far-reaching implications, not only for our solar system but also for our broader understanding of planetary systems across the galaxy. The study of Pluto's orbit also highlights the importance of collaboration within the scientific community. Astrophysicists, astronomers, physicists, and mathematicians all contribute their expertise to the study of Pluto's movements, each offering a unique perspective on the issue. This collaboration has led to the development of more refined models of planetary motion and a better understanding of the delicate balance that keeps the solar system in harmony. Although Pluto's potential collision with Neptune may seem like a distant possibility, it serves as an important reminder of the ongoing challenges we face in predicting the behavior of distant objects in the universe. The chaotic nature of celestial orbits means that even the most seemingly stable systems can be subject to sudden, dramatic shifts. As we continue to monitor Pluto and other distant bodies, it is crucial to remain open to the unexpected and to constantly refine our models based on new observations and discoveries. As our exploration of space advances, we are continually confronted with a vast unknown. The story of Pluto's orbit represents the sense of wonder and curiosity that drives us to explore the universe. Even as we uncover more about the planets and moons that make up our solar system, we are reminded that there is still so much to learn. The potential for a future Pluto-Neptune collision, while uncertain, encourages us to keep seeking knowledge and to remain ever curious about the mysteries that lie beyond our reach. In the grand scheme of the universe, Pluto's movements may seem insignificant, yet they serve as a microcosm of the larger forces at play in the cosmos. The gravitational dance between Pluto, Neptune, and other planets is a small-scale example of the intricate and interconnected nature of celestial mechanics. It reminds us that everything in space is in motion and that even the smallest objects can have a profound impact on the larger systems they are part of. Ultimately, the story of Pluto and its possible interaction with Neptune is not just about these two distant worlds. It is about the broader quest for knowledge and understanding in the field of astronomy. It is a reminder that, no matter how much we know, there is always more to discover. The universe is full of surprises, and as technology advances, we will continue to unlock its secrets, one discovery at a time. The possibility of a collision or close encounter between Pluto and Neptune, while unlikely, serves as a powerful symbol of the mysteries that still lie ahead in space exploration. The future of Pluto's orbit is uncertain, and we can only wait to see how the forces at play will unfold over time. But one thing is clear: the more we learn about Pluto, Neptune, and the rest of the universe, the more we realize just how much there is still to discover. As we continue to study Pluto's movements, the gravitational effects of other planets, and the complexities of orbital mechanics, we are reminded of the vastness and intricacy of the universe. The story of Pluto is far from over, and with each new discovery, we come closer to understanding the true nature of our solar system and the cosmos beyond. Whether Pluto and Neptune will continue on their separate paths or one day collide remains an open question, but the journey to answer that question will continue to drive the quest for knowledge and exploration.